Okay, we are recording now. All right. This is taking it from the very beginning. Okay, so today that we were talking about story problems, and so you have 6 that you needed to work on. It froze. There we go. So there were 6 problems you needed to work on. We did 1 in class. You were estimating about how many books did the library receive. We talked about that. Take out the number in the story problem and talk about what does that story tell you, and then put the number back in to see if you're going to be answering the question. Importantly is to look at the question, how many books did the public library receive? We said that they received a certain amount, so we know that we're going to add it because we're combining the books. So we had 12,245 nonfiction books and 9,238 fiction books. Remember that you're labeling. We said that we were going to be expanding these and then adding those up, which will give us parts of the answer to get us to the total answer. So we took the 12,245 and we broke that down to 10,000 plus 2,000 plus 200 plus 40 plus 5. We took the 9,238 and we broke that into 9,000 plus 200 plus 30 plus 8. Then we took the ones and added that up. I have 13 ones. We moved into the tens. We added that up. We have 70 tens. We went into the hundreds and I added all my hundreds and I had 4 hundreds. Went to the thousands and I had 2,000 plus 9,000 is 11,000. Then in my 10,000s, I had a total of 10,000. Then I said I'm going to take some groups and add those up together so that I can see what, getting to the actual total, how many books did the library receive in all, right? So I have 10,000 plus 11,000, and I said it was 21,000. Then I added 400 plus 70, and that gave me 470, leaving my 13 ones that I'm going to add in. Once I added it, I had a total of 21,483. I wrote in a complete sentence of the total number of books received was 21,483 books. Standard algorithm, the reason we're doing this is so that you can understand, yes, it looks differently, but it has some similarities, and here it is. So when we put this in standard algorithm, let me move that out of the way. We're looking at our ones, and we said that we had 5 plus 8 equals 13. We regrouped. See how I put the plus 1 here? In our minds, we always say, oh, what's 3 plus 4 plus 1? But it's actually what is 30 plus 40, and then we have our regroup of our 10, and that gives us 80. So if we see right here, I now have 83. Now I'm moving over into the hundreds. We say in our mind 2 plus 2, but we really mean 200 plus 200, right? So I know that it's 400. Well, look at what's in the hundreds place value. Look at what's in the hundreds place value. Still the same? Absolutely. Now we're moving over into the thousands place value. And we usually in our mind say, what is 9 plus 2? But it really means what's 9,000 plus 2,000? And we said it was 11,000. So I have bring down my 1 and I regroup the 10,000 over here. And so now I have, in our minds, we say what's 1 plus 1, but it's not really 1 plus 1. It's 10,000 plus 10,000 equals 2 or 20,000. And so we end up having 21,483, which is the same that we did here when we did an expanded form, adding up parts of the sum. Okay, so let's go ahead and work on the other ones. And you don't have to complete this evening. This is a practice so that you're able to understand place value and how the partial sums or the expanded form, when we're adding them up, have a relationship with the standard algorithm. So this about the family traveled 148 miles last summer. This summer, they traveled 10,089 miles across the United States for a total of, oh, they drove across for a total of 10,089 miles. I misread it. So this summer they drove, because this is supposed to be the word summer. So last summer they drove 3,148. They drove some miles. This was last summer. And this summer they drove so many miles. And it says how many miles did this about the family travel these past 2 summers. So we want to find out, what are we going to do? Well, it wants us to know total amount. So yes, we're going to be adding it. So let me go ahead and highlight that in yellow. And I know that we will, and the word was together. So this is going to be my keyword, which means add. So when I write down my numbers, so I'm going to estimate first. I have 3,148. Remember, the squiggly line means about 3,000. And I have 10,089 miles. That's about 10,000. So I'm going to say they traveled about 13,000 miles altogether. Okay, all right. Now we're going to break these numbers apart. And so I'm going to start off with, I'm going to put 10,089. That's this summer. And then it's 3,000. I'm looking in my thousands house. I need to make sure I pay close attention to my place value. So it's 3,148. I'm going to go ahead and but identify my place value houses. So this is ones, tens, hundreds. Here's starting in my thousands. So this is 1,000 and this is 10,000. I'm going to add these up. But remember, I'm doing it. This is not the standard algorithm part. So I'm going to break this up. We have, and the way we look at it, the digit in the 10,000ths part is 1. The value of that 1 is 10,000. There's nothing in the thousands. So I'm just going to, because I have others, I'm just going to do that to have my zeros hold the spot. Okay. Then I'm going to look in the hundreds. This is going to be plus. There's nothing in the hundreds. I'm going to just do that to hold its spot. I have 8 tens. So I have 10,000. I have nothing in the thousands. I have nothing in the hundreds. And I'm going to just keep moving. I'm going to just kind of extend it over. I have 80 plus 9. 9 ones is value of 9. I have 8 tens, which is 80. I have no hundreds. I have no thousands, but I have 1 10,000. And I'll show you why I did this. So now let's look at this one right here. I have 3,000. I don't have any 10,000, but I do have 3 in the thousands, which gives me a value of 3,000. So do you see that? I have 1 in the hundreds, which gives me a value of 100. I have 4 tens, which gives me a value of 40. And I have 8 ones, which gives me a value of 8. Now I'm going to add these up. I know that 10,000 plus, well, look at this. It's only 3,000. This is going to give me 13,000 because I'm adding. Actually, let me just start from here, from right to left. What is 9 plus 8? I'm just going to come over. Let's just start routinely right to left. 9 plus 8 is, very good, 17. Can make that break my houses up. Okay, 80 plus 40. Very good. 120 plus 100 plus 0. Very good. It's 100. Plus 3,000 plus 0 equals, very good, 3,000. Plus, and then you have my 10,000 because there's nothing else. All right, now that we've added that part up, I still have to put my number together. What is it? So 10,000 plus 3,000 equals 13,000. 100 plus 120 is 220 plus 17. So that's 7, 2, 3, 2, 3, and 1. So 13,237. Now let's see if we're good. So let's go to the standard algorithm. And again, we normally wouldn't add this way, but sometimes you're going to see it spelled out that way. And are you able to identify it and know the process? I'm going to take my 10,089, which is miles this summer. Hit S for summer. There you go, I just spelled it out. Then I have 3,148, and this is miles last summer. And I'll put last summer here. All right, we would normally say what is 8 plus 9, and we said that that was 17. Okay, do we have a 7 here? Yes, we do. I'm regrouping. Remember today we talked about put a plus in front of your regroup. We would normally say 4 plus 8 plus 1, but we should be thinking 40 plus 80. But what is 4 plus 8? We said it was 12 plus 1 equals 13. So far, do I have that? I have a 3 and a 30. I have my 3 and my 7. 3 in the 10s, 7 in the 1s. So yes, we're good. I'm going to regroup my 1, not in this one, but over here. So what's 1 plus 1? That's 2. But we wouldn't say 1 plus 1. We would say we're thinking 100 plus 100 to give us 200, but we say 1 plus 1. I'm going to put in my house comma for 1,000. 3 plus 0 equals 3. So far, do I have 3,237? Yes, we do. And now I'm going to bring down my 10,000. And do we end up with 13,237? So that's how many miles they traveled. And that's finding that relationship. The place value is so important as we move on before getting into the next unit. So here, the Zapata family traveled 13,237 miles altogether. There you go. And that's what you would write. Is this reasonable to our estimate? Absolutely. It really is. You're going to do this the same way over here. We're looking at a larger number, but here you have 1,473,675. Okay, what is that closest to? A million. What about 1,400,000? You have 2 million, and of course I want you to go back and read it, taking the numbers out. And these are people voted. You have 2,076,000. Okay, so this is going to be about 2 million. This is going to be the people that voted in Florida election in November. And this was last year. So last year in Florida, last year voted. This is this year voted. Okay. How many people voted in Florida during the past 2 elections? So we want to find out how many people voted in Florida. So I know that this is going to be an addition problem, because I want to know how many people voted. And then we have our last year. Here's the number of people from last year. So we have a certain amount of people that voted last year and a certain amount of people that voted this year. How many voted in all? So I'm going to say about 3,400,000 people voted. So as I add this up, this is 3,400,000 people voted. This is about because we're estimating. Voted all together. Can y'all read that? Kind of squishing it in. All together. And you're going to do the same. Breaking this up. You will probably, some of you have taken home some of the graph paper and look at that, and then doing your standard algorithm where you have 1,473,675, and you have your 2,076,014, and then you add it up. Doing it on graph paper, remember that's your standard algorithm comparing your place values. I'm going to go ahead and move it over here, and I'm going to take my 1,473,675, this is last year, votes in Florida. This year's votes, did it increase or decrease? If we were comparing it, yeah, the 2 million is greater than your 1 million, so we increased in votes. So this is this year's votes. All right, now let's break it down. I'm going to have 1 million. I probably will have to okay, that's my 1 million. I should have done my comma right here. Plus, remember this is ones, tens, hundreds. This is 1,000, 10,000, 100,000, and then 1 million. So I have 1 million plus, how many are in the 100,000s? 4. The value of 400,000 is 400,000. And it's being able to get used to expanding it because it's place value. Going into my 10,000s, I have 7 in the 10,000s. The value of 7 10,000s is 70,000. Next, I have 3 in the thousands. The value of 3,000 is 3,000. Not quite done yet. Then I have 6 in the hundreds, so this would be 600. And I'm going to do what you would normally do at home, and this is what I would do if I were at home, because I only had one graph paper. I would just continue writing it on paper. So I would get a sheet of paper and just continue, because that's the best thing I can do, right? So 7 tens equals 70. 5 ones equals 5. All right, so that's what it would look like. It's a very long one. Kind of move this. All right, and there we go. Now I'm going to take the next one, and this is going to be 2 million. Yes, I hear somebody, I wish that was my bank account. I would do too. I really do. I don't have anything in the 100,000, so I'm just going to place my zeros as my heroes to hold my spot. But I do, look at this, I have a 7 in the 10,000s, so that's kind of repeating itself, right? So it's 70,000. Then I have 6,000. Then I have no hundreds, but I have 110. And 4 ones. And that's what that would look like. Trying to squeeze it all in. There, can we get it? So that you can just see the bigger picture. Still not quite there, is it? Okay. I can't get this thing any smaller. Let me see if I can do something. I'm going to really pick it up here. Maybe that will work. Almost, right? I almost got it. Not quite. All right, so I'm going to go ahead and add. I'm going to bring this over here. And this is going to be added together. Okay, 5 plus 4 equals 9. I'm in the ones. This is my tens. 70 plus 10 equals 80. Then I'm in the hundreds. 600 plus 0 equals 600. 3,000 plus 6,000 equals 9,000. 70,000 plus 70,000 equals 140,000. 400,000 plus 400,000, 0 is 400,000. Wanted to give it more numbers than it needed. And 1 million plus 2 million equals 3 million. Very good. All right, now let's kind of chunk these together. I have 3 million, and I added 400,000 to that. That's going to give me 33,400,000, right? Then if I have 140,000 and I wanted to add 9,000 to it, I'm going to have 100, oops, wrong spot. I'll get a mark. 140,000, 49,000, that's a 9 right there. Going for the white out. Yay! I just want to make sure that we don't get confused here. Big numbers, they make it a little bit more complicated. Just because they're big, we're not used to working with big numbers. And we're going to, and it's okay. You may get a little frustrated. I get it. I definitely do. Again, this is that practice that we're getting in. So I have 149,000 and then plus 600 by itself. And then I have 80 plus 9. If you're wanting to, so you can do it like this, you can add your 3 million and then your 400 and then 140 plus your 9 plus your 6. You can do that, absolutely. You don't have to chunk it up this way. It's up to you. 0 plus 0 plus 0, 9. 0 plus 8 is 8. 6, comma, 9, 4, 4, 5, 3. So it should be 3,549,689 votes altogether. So let's see if it works on our standard algorithm then. Remember, we're going to be comparing these numbers. 5 plus 4 is 9. Is that what I have here? 7 plus 1 equals 8. But we don't say 7 plus 1, right? We say 7. We're thinking, we do say 7 plus 1, but we think 70 plus 10. 600 plus 0, but we say 6 plus 0 equals 6. Is that what I have so far? 689? Very good. Next, we don't say 3,000 plus 6,000. We say what's 3 plus 6, and we say it's 9, but we also know it's 9,000. 7 plus 7 is 14, but we also know it's in the 10,000s, so it's 70,000 plus 70,000 equals 140. So we're regrouping. 4 plus 1 equals 5, but it's actually in the 100,000s, so look at that right here. And now let's look at our millions. 2 plus 1 equals 3. So did we get 3,549,689? Yes. So that worked out beautifully. But I did mine on a separate sheet of paper, and I'll show you tomorrow. All right. What I want you to do is just to go ahead and practice on the other ones, just in case you didn't get any of the corrections, to let you know on here. It's not just man in Dallas, but it was the lucky man in Dallas, and he decided to purchase 2 homes for his family. The first home cost, and then you'll say it without the number, but I'm going to read that, $176,899, and the second home cost $98,413. How much did the man spend on his 2 new homes? Estimate it, partial sums, and your standard. LeBron James, we're going to do the same thing. We're looking at his money, how much he earned. This is pretty accurate, I believe. I would have to Google it. So LaMarcus Aldridge earned $19,697,403 during the 2019 basketball season. How much money did these 2 NBA players earn all together? Keyword all together means to add. Remember what you need to do. So estimate, partial sums, and standard. And then lastly, in case you did not get it, this was the Coca-Cola Company. You still have your numbers here. So they filled 189,405 cans of Coke Zero on Monday. Then on and 213,870 cans on Tuesday. And this was of the regular Coke. So how many total cans of Coke and Coke Zero did the factory fill on those 2 days? So we want to find on the adding again. Remember, you're going to estimate first to find the reasonable answer, then the partial sums and standard algorithm. This helps on place value. If you run out of time, just try to get at least one more done. And then we will go over the rest tomorrow because we're going to move into the subtraction part and then go into multiplication. All right, guys, you have a great night, and I will see you tomorrow. It was a pleasure teaching you today. and we'll see you then. Bye.